Okay, accuracy versus precision. Accuracy is how close the measurement is to the true value, and precision is how close the set of measurements are to each other. And I explained that to most of you throughout the lab because there was that question on it. But accuracy, so our density of the lead was 11.3, and most people were pretty accurate. There were a few that were not accurate. But sometimes if your measuring tool is off, let's say the balance was off, so the mass that everyone got was always off by the same amount, you would still have very precise measurements. So all your measurements would be close together, but they wouldn't be very accurate because you don't have the correct mass measurement. And then sometimes you can get a wide range. So is the first one accurate, precise, neither, or both? Both. Both. And how about the second one? Precise. Not accurate. And the last one? Neither. Very good. And then dimensional analysis, this is what I thought we'd already done notes on and what that worksheet is over. So this should help with your worksheet, hopefully. But dimensional analysis is just a method of using units in order to convert to new units. And these are the steps they give us. So you determine what unit conversion factor is needed, like 1 meter is equal to 1,000 millimeters. That would be a conversion factor. And we will use what I call a railroad track method, but we're going to be able to show that we're going to use units in all of our conversion, and then the units should cancel out until you are left with your desired units. And it's always a good habit to carry your units through so you know whether to multiply or divide, and also you can see if your units do not cancel out, you've done something wrong. And they just show us this. And I think this book does write it this way, whereas I would, and I'll show you, we're going to use a railroad track. We're not going to put times in a fraction. We're doing the same thing, but we're just going to write it in a more simple form. So like here, how many milliliters are in 1.63 liters? Here's our conversion factor. And if you can do metric system is a lot easier. You can sometimes just move the decimal point. But this is why we are able to just move the decimal point, because we have 1.63 liters, and these are the railroad tracks we're using. Liters, how many milliliters are in a liter? 1,000. In order to get liters units to cancel out, liters have to go on top or bottom? Bottom. So now we're taking a liter divided by a liter, which cancels out, and 1 liter is equal to 1,000 milliliters. So then we'd multiply by 1,000 or move the decimal to the right 3 spots, and you do get 1,630 milliliters. Now when we're using the metric system, if you know the units well enough, you can just move the decimal. When we get to some of the derived units, it'll be a little more complicated, where you might want to write these out. And then when we get to conversions using moles and the molar mass, atoms, molecules, will always want to write out our units. Okay. Oh, they're going to go through this all for us. So you see how they write it a little differently? We're doing the same thing. Yes. They're saying you cannot do it this way because the liters don't cancel out. This is the units you would end up getting, which is not correct. Wow, there's a lot of little. Okay, this one, the speed of sound is 343 meters per second, and they want to know what that speed is in miles per hour. There must be, there we go. We need that conversion. So if we have 343 meters per second. Oops, let's write that differently. For derived units, if you write it meters per second, that works this way. That way you can tell what units on top and what units are on bottom. We have to convert both the meters and the seconds. It doesn't matter the order. Which one do you want to convert first? Meters. Okay. So meters have to go on top or bottom here? Bottom. And we can change meters straight to miles using this conversion. And what numbers would we put in here? 1 mile. There we go. So meters canceled out. We're left with miles, which is what they asked for. So now we can change seconds into hours. Since seconds are on the bottom here, seconds need to go on top. Do you know how many seconds are in an hour? Right. If you wanted to, you could go seconds to minutes and then minutes to hours. That would be fine. And I always put a double line to show myself that I'm done. I have the correct units, miles over an hour. Now you would just multiply by the top numbers, divide by the bottom. And what value do you get? How about in significant figures? We have 3 here, so we want 3 in our answer. So yep, 153. Conversion units, we don't have to count. We don't use the significant digits in the conversion units. They're considered exact numbers. So just the measurements, which would be the 343. Does everyone agree with 153? Yes? No? You don't get 153? Uh-oh. I have lots of 767s. Why you guys need to speak up. What'd you get? 767? There we go. Okay, so they're going to go through this whole thing. What we just did. I should delete all that off the slide. 767. Okay. Person's average daily intake of glucose, which is a form of sugar, is 0.0833 pounds. What's this mass in milligrams? So how much, what are we converting? We're converting the 0.0833 pounds, and we're converting it into milligrams. You know what? Let me just get a new sheet. It gave us a conversion factor of 1 pound is 453.6 grams. So how would we use that here? £1 on the bottom, and that way our pounds cancel. And is this the unit that they're asking for? No, we need to change that into, okay. How many milligrams are in a gram? So does grams go on bottom or top? So 1 gram is 1,000 milligram. Now we're in the correct units. So now we're going to multiply everything together. And how many milligrams do you get? What? 37,000? 800? Yeah, because look, we only have 3 significant figures here. So our answer should just have 3. Now, I'm not going to, in all your problems, I'm not going to take off points if you don't answer the correct number of significant figures, unless it specifically asks for the correct number of significant figures for this class, okay? I don't want like 7 decimal places or anything. So try your best at always using significant figures. And what would our units be? Milligrams. Okay, average adult has 5.2 liters of blood. What's this volume in meters cubed? 5.2 liters. So we have 5.2 liters. And it gave us a conversion of 1 liter is 1,000 centimeters cubed. So liters go on top or bottom? So 1 liter is 1,000 centimeters cubed. But it wants meters cubed, right? How do we change centimeters into meters? Well, how many centimeters are in a meter? Mm-hmm. Is that all we do here? Now, centimeters cubed mean it's a centimeter times a centimeter times a centimeter, right? So by doing this, we've canceled out 1 centimeter. Now we're left with centimeters squared. We got to do that 2 more times. Or you could just cube this, but we'll just go, we'll show all of them this time. So that way this one cancels. And then there we go. Now we've canceled that out. And we're going to be left with meters times a meter, which is meters cubed. So we're actually moving the decimal 2, 4, 6 to the left and 3 to the right. And what do you get? .0052? Is that right? If you look, you could cancel these 3 zeros, cancel out 2 of them, so you'd have 1, 2, 3. You're moving the decimal left 3 spots. If you want to do that, or you can punch it in your calculator. Either way. Is this the last one? Yep. So how about you guys start in on this one, and then we'll compare everyone's answers here. Yeah, that's how it should be set up. You should get what you guys got? Because you got to change centimeters into meters cubed. Why is it cubed? You could write it out 3 times like we did in the last one, or you can just show it as it's 100 cubed. There's 100 cubed centimeters and 1 cubed meter. Or you can write it 3 times like you did the last one. What? 808? Okay. No?
Got it. I got it.
So you should take 0.808 times 100 cubed, which would have 6 zeros. Y cubed. Because remember, this is centimeters cubed, just like that last problem. So if we have remember, if this is like a centimeter times a centimeter times a centimeter, and if I just put this here, I'm only canceling out 1. So I'm going to do this 3 times. Or basically you're cubing it. It's the same thing. So you could write it down this way, and that would be fine. So now you've canceled out all 3 of them. But that's the same as cubing. 100 times 100 times 100 is the same as 100 cubed, right? Does that help? Okay. So you can do it either way. You'll get the same answer. You can write it out 3 times or you can cube it. Questions on dimensional analysis? Does that help with your worksheet? Okay. Grab your clicker. They're over here this time.
This is like first day physics.
Mm-hmm. Next chapter. All right. Your guys' test actually fell on Friday, but I know all the activities are gone on Thursday, so I moved it to Tuesday. I don't like Monday tests. We will never have a Monday. We might have Monday quizzes, but not Monday tests. So your test will be on Tuesday. For any of it? To finish it. So what do you have? That we ended up not doing C. We didn't have time. So go ahead and do everything just based on those 2. Yes, element quiz 4 is tomorrow. I need to fill out the board. Okay, you guys can go ahead and answer this question. There is. I copied this from the C4L. Did I explain that the last time? It came from the test bank that the teachers wrote, and so there's a mistake in that. Is that the correct answer? It is B. Oh, no, you can only do this one. Which term describes the set of steps used to test a hypothesis? And lots of C's, a couple A's. Answer is C. Yes, experiment when you're testing the hypothesis. What would you use to accurately measure volume? Ooh, lots of C's. An AC. Yes, the answer is C. So a beaker, even though it does have volume measurements, if you were to measure something in a beaker and then pour it into the graduated cylinder, you'd see it's not very accurate at all. Okay, so don't ever measure volume of liquid in a beaker. An Erlenmeyer flask really has no way of showing a volume. Oh, come on. There we go. And then a round bottom flask has no volume either. We don't ever use a round bottom flask. The only other thing that's more that you could use other than a graduated cylinder is a volumetric flask, the ones with the really skinny necks, but they can only measure one volume. You can't, it doesn't have the graduations like a cylinder. Next one. Lots of A's. The answer is A. Yes. So B is an actual variable, so something that's going to change. Hypothesis is your educated guess that you make, right? Looking for the dependent variable in this experiment. Okay, so which one is responding to a manipulated variable? Ooh, wide range. The answer is B. Yes. Because she is, it's the effect of temperature on the rate. So temperature is what she is controlling, or the student's controlling, and then the rate is dependent on the temperature. Changes based on what temperature it would be. Where should laboratory instruments be read to avoid parallax errors? Did we talk about parallax? Parallax.
Seniors, you may report to the auditorium for class meeting Please bring a writing utensil.
Would be an error of measurement based on where your position is. Kind of like your speedometer. If you are in the passenger seat, does it look like you're going the same speed as the driver sees? No, that's a parallax error. Okay. And number 4 is Remington. So answer is yes, at eye level. Okay. So whenever we have, like, reading the bottom meniscus, go down to eye level to read that. Measured or units for volume in the metric system. Remember, it's just the metric system, or volume. This one doesn't look as good. What? What's what?
It means it's a centimeter.
Yeah. I copied it straight from there. It's not a... There's a lot of mistakes, huh? Answer is B. Yes. A meter and liter are volume units. Is a gram a volume unit? No, it's a mass. Milliliters, well, B is right. And then C, those are all volume units, but they are not metric volume units. Yes.
So is that in a variable or whatever worksheet you
Yes, your dimensional analysis sheet is due tomorrow. And then these problems are due on, what was it, Thursday? Thursday. And those are all at the end of your notes there. Yep. Yes, you may put this way.